Continuing, we talked about factoring divided by the highest power of x in the denominator, and I can't think of the top of my head. I'll factor in highest power of x in the denominator multiplied by the conjugate. So looking at this, can I factor? I say, okay, well, probably not. Can I, divide by highest power of x in the denominator? Possibly, but would probably make the problem a little bit more messier. The best thing to do right here is multiply by the conjugate, right? Anytime you have some sort of square root multiplied by another term, added or subtracted by another term, we could clean up that numerator. And here's what I mean. Multiplying by the conjugate says that the first term, I'm going to keep the first term alike. And so this is x squared plus 12. And I'm going to change the sign plus. So this is the opposite sign of here, plus 4. Whatever I do on the top is whatever I'm going to do on the bottom. Plus 4. Put a parentheses here. Look what happens to my numerator now. So the limit as x approaches 2, well, the square root times the square root is 0. Or matter of fact, it's 1. So basically, the square root goes away. So this now becomes x squared plus 12, right? Well, a negative times a positive is always a negative, right? Well, 4 times 4 is 16. You see? Now, a lot of students, including myself, when I did not know, want to distribute this x minus 2 back into this. It won't do us any good. Is it possible? Probably. But it won't do us any good. So anytime you multiply by the conjugate, you always want to clean up. So if you're multiplying by the conjugate by the numerator, you clean up the numerator, but you leave the factors in their exact form. So what do I mean? I'm not going to distribute this x minus 2 into here. I'm going to leave it as is. So x minus 2 times the square root of x squared plus 12 plus 4. And basically what this does is that it allows me to cancel something. It allows me to cancel something. So the limit as x approaches 2, well, this is just x squared minus 4, right? Over x minus 2, square root of x squared plus 12 plus 4, right? So immediately I could see that my top could factor. This is a difference of squares, so this is actually x plus 2, x minus 2, over x minus 2 times the square root x squared plus 12, right, plus 4. These cancel, right, and so the limit as x approaches 2, x plus 2 over x squared plus 12 plus 4. Plugging in that, well, 2 plus 2 is just 4. 2 squared is 8. 8 plus 12 is 20. Alright. 2 squared is 4. No, I'm sorry about that. 2 squared is 4. 4 plus 12 is 16. The square root of 16 is 4. So 4 plus 4, and that's going to give us 4 over 8, which simplifies to 1/2. Yes? Let's look at another one. The last one, in fact. Looking at this problem, I say, okay, well, what is going on? All right, so I see a negative 1 here. And usually, as you guys will learn further on in calculus, anytime you have a power, anytime you have a negative power, you want to flip that to become positive, right? Because it's going to make your life much more easier. So I'm going to flip this negative 1 to just be 1 over x. This is the same thing as x to the negative 1 power minus 1 divided by, my focus is given out here, bear with me, x minus 1. Right? Now we could simplify, but to simplify, we have to clean up this top first. So I can multiply this by the x. So I got to get a common denominator. Whatever I do to the bottom, I do to the top. And this will be x. Yes? All right. So the limit, forget my 1 here. Sorry about that. The limit as x approaches 1 of 1 minus x, because 1 times x is just x, minus, well, 1 minus x over x, because we could combine these x's now, right? Yes. Divide by x minus 1. Yeah. Right. And I'm going to put this divided by 1, just so when I multiply, I do not make a mistake. Right. So the limit now, as x approaches 1, is going to be 1 minus x over x multiplied by 1 over x minus 1. Yes? Right. So the limit as x approaches 1 is just 1 minus x over x times x minus 1. If you plug in 1, we still get 0 over 0. Right? This is still indeterminate. So this is something you just got to realize, and it's just helpful to know. There's nothing else we could do. We can't multiply by conjugate, nothing else. But what I realized, I could factor out a -1 in the top. You see? So factoring out a -1, this now becomes x minus 1 over x minus 1. Well, how did this change from this to this? Right? It's kind of confusing. But remember, I could also rewrite this, right, as -x plus 1. Right? This is the same thing as this. You agree? So taking out a -1, -1 would just be x minus 1. Right? -1 to -x plus 1, which is the same thing here. These are this and this is the same thing. So basically the same thing I did here, just did it in a quicker step, but I want you to see where I'm coming from. So now we can just cancel. Yes, so the limit as x approaches 1 of -1 over x is actually -1, because now we can just plug in -1. Oh, I'm sorry about that. We could plug in 1 in for x, and that would just give us -1.